I would just like to introduce Extrema and how you can find them if you have a graph. So I'll write that word. So Extrema. So when you see the word Extrema, we're talking about maximums and minimums. Okay, so high points and low points. And we mean, when we talk about it, either in the vicinity, which would be a local, or an absolute maximum or absolute minimum, which would mean for the entire function. So, and I know it's difficult to see, but I can't zoom in anymore, so I'll read off the coordinates there in case you need to know them. But you can kind of point. So if I asked you, hey, can you find all of the local maximums? So you would just find all of those high points. Okay, so all the times you reach a top and go back down. So here's one. And now it gets a little tricky because you have to decide, are you being asked for the y value? What is the maximum value the function takes on? Are you being asked for the point where that happens, in which case you'd put both parts of the coordinate? Or are you asked for the x value where that occurs? Can show up either way. So let's just assume that I mean find the local maximum function value. That's the y part. So for this function, right, here's a high point right here, and the point I've labeled it C, D. So there's a local maximum when y is d, right, and then it goes down. It hits that high point, it goes down, it comes up, it hits this point here. That y value is h. And then it hits this point here, and that value is m. Now, when you are asked for an absolute maximum, that means what's the highest y value the function takes on over its entire domain. Okay? So this function, notice it has big old dots, right, stopping and starting my function graph, so it doesn't go on forever, because that would change my response. Right? So we have an ending point, and this ending point is above all of the other points on our graph. So that's an M, LM. M is the absolute maximum value that that function takes on. Okay, local minimums. So I've got, right here's a low point. That point's AB. This point here is EF, and this point here is JK. So AB is a minimum, so B, the y value. EF, so F, and JK. And then if you had to pick the absolute minimum, the lowest point anywhere on the graph, it would be B. Okay, so let's do one more example. So here's a different graph, and now I only have 3 points labeled. I have AB down here, CD up here, and EF down here. And you'll notice I have arrows on the endpoints of my graph. That's important. Okay, so let's take a look. Local maximums. Any high points in the area, any time when we come up over the top of a mountain and get to look down the other side. Yep, up here at the top, up there at the point CD. And again, we'll just give the y value. Do I have any more? Well, right, these arrows are going to go on forever upward. So I'd never reach a final point that's higher than any other point in the vicinity, because there's always one more higher if I just keep going. So this one would have none. No absolute maximums. Okay. What about some local minimums? Any local low points? So bottom of the hill before you have to trudge back up. So here's one down here at B. Here's one down here at F. Then absolute minimums. Are there any points that are lower than any other point on my graph? And in this case, there is one of those, that point EF. So just the y value, though, would be F.